So a system of linear equations has three possible outcomes. The most likely one is that we have one solution. And so what we're going to do is we'll make a model, a graphic model of what that looks like. I'm going to make just a quick coordinate plane. So here's a coordinate plane with an x and y axis. So one possibility is that the system, well, remember, this is a linear system. So in theory, we have two lines, right? And when you have one solution, how do those two lines interact? What do? They cross at one point. Since they're lines, they're only going to touch at one location. So let's say we have a line that does something like this. Okay. And another line that crosses like so. And right here, wherever this xy coordinate is, you have a solution. And that's the one solution. Wherever the two lines intersect. So remember we started solving these by graphing. Then we moved on to substitution. And then now we've been doing elimination lately. But all of those represent, whenever we get a solution, the location, the point where those two lines cross. Okay, that's the one solution. Okay. Then we had a possibility of having no solution. So let's take a look at what a no solution should look like. Again, we'll make a quick sketch. Okay. And whenever you have no solution, that represents two lines that never touch. Because wherever they touch, they have a solution. So in order for there to be no solution, the two lines can never touch, which means that the two lines are parallel. So no solution means you have parallel lines. Because they never touch. Okay. So that's a one solution, no solution, and then we can have infinitely many solutions. And this particular case is when we have two lines that coincide. Same slope, same y-axis. So let's say I have a line doing something like this. And I graph my second line. and it coincides. Basically, they're on top of each other. They touch at infinitely many points, and every one of those points they touch at, it's a solution. Okay. So there's our visual description of what we're going to do algebraically right now. Okay. So tomorrow we'll look into graphing these again. But for today, I want you to be able to recognize when these three things happen without having to graph. Okay? And it's actually pretty easy. So let's do that. And so the first is going to be when we have one solution. I want you to look at a case when we have one solution. And it's going to look very familiar. Okay, so you guys ready? So this first one will be a case where it's one solution. Is that mine? In the back? Oh, that's somebody's phone. Put it on vibrate, please. All right, so here's the system that will give us one solution. 5x plus 4y equals negative 30, and 3x minus 9y equals negative 18. Okay, write that down. Here's the system. And it is going to give us one solution. And the way you determine this is you just try to solve it. Just try to solve the system and see what happens. Because right away you're going to see either it's going to go the way we've normally been expecting it to happen the last few days we've been solving, or something different is going to happen. Okay? So let's have a look. Well, let's try to solve this. We have 5 and 3. They're not opposites. 4 and negative 9. The signs are opposite, but the numbers aren't. So we can either get 15 or 36. 15? Okay. So that means we have to multiply both. We have to multiply both of these by something. And one has to be negative because we need opposite signs. So let's make negative 3 here and positive 5 here. That way we'll get negative 15s. Okay, so let's see what that gives us. Let's move forward. So we're going to go negative 15 x. Negative 3 times 4 is negative 12y equals 90. Okay. Now, next, we're going to multiply here by 5. So this is going to be 15x minus equals negative 90. Okay. Well, what's going to happen? Is anything going to cancel at this point? If I add these two, these would cancel, right? And then this would be negative 57 y equals 0. Okay. Am I going to get an answer, though? Yeah. Divide by 0. I mean, I'm sorry, divide by negative 57. Y equals 0. Okay. You could stop right there. I got a value for y. It's 0. I mean, but isn't 0 a number? So the moment you get x equals something or y equals something, you could stop because we're not interested in the actual solution. We just want to know, are we going to get a solution? And if I continue, am I going to get a solution here? Can I go on and continue and solve for x? Yeah. All I got to do is substitute in 0 for y and continue solving. I'm going to get something for x, and I'll have a solution. So once you find either x or y, so I'm going to write that down because it's important that you understand this, guys. Once we know that we're going to get an answer for either x or y, once we are able to determine a solution for x or y, then we have a solution. Or we have one solution. So we were able to determine that y equals 0. Y could have equaled -5. Y could have equaled whatever number it is, even a decimal, even a fraction. Doesn't matter. Once we're able to determine some value for y or x, stop there and you say, okay, I have a solution. Okay? So this is an example of finding one solution. Any questions? So you just try solving it like you normally would. Once you determine, okay, you get to this point where you canceled one of the variables and you're getting an answer for the second one, you're good. You got a solution. That's one solution. Questions? Okay, so this is an example of a one solution. If I were to graph this, it would be something like this one. Let's do a no solution. You guys ready? We're going to do a no solution. So all of these problems today, you're going to get halfway through the problem and you're going to realize what you have. Okay? So this will be a no solution. Okay, here we go. No solution coming up. Let's do -2x minus 6y equals -1, and -x minus 3y equals 1. Okay, so here's another system. And we want to eliminate. Okay, let's say we want to eliminate here, because really this is -1, right? Let's say I want to eliminate x's again, just because they seem easy. What's the least common multiple between 1 and 2? 2. So I already got a -2 there. I just want to multiply the bottom one by -2. If I multiply by -2, this will give me positive 2x, which will give me the opposite there. Okay, let's do it. So I'm going to leave the top one by itself. Nothing's going to change there. The bottom one will multiply by negative 2, so that's going to be 2x plus negative times negative is positive 6y, and then it's going to be negative 2. Okay? So if I do this, combine them, as promised, negative 2x and 2x cancels. However, what else cancels? Negative 6y and positive 6y, that's going to cancel. So on the left side of the equation, we have, what's on the left side now? If everything went away. Well, okay, on the other side, it's negative 3. But on the left side, 0. So I end up, we've been down this road before, remember? Yeah, this is a statement. It's a false statement, most importantly. Here we end up with a false statement. 0 is not equal to negative 3. Therefore, no solution. So guys, if you're on your merry way solving this system like we've learned to do, and everything on the left side goes away, you're left with 0 on the left side, and something on the other side that's not 0, then guess what? That's false, therefore no solution. Okay? We ended up with a false statement because 0 does not equal negative 3. Therefore, we could say there's no solution. Basically, what we would have are two parallel lines. If we were to graph these, you would see that they'd be parallel lines. But we didn't have to graph. You just start solving it like you normally would. So there is our example of a no solution. Okay. Last one. You guys ready? Let's do a infinitely many solutions. Infinitely many solutions. Okay, so something similar to what we had here is going to happen, except you'll see that we're going to end up with 0 equals 0. Okay, so here's something that would give us that. Let's do 4x minus 12y equals 22, and negative 2x plus 6y equals negative 11. Okay. What do you notice? Just before we even do anything else. Yeah, Jesse.
I noticed that for the equal sign, half of the top one is a negative.
Yeah. This
And
is,
it's opposite, maybe.
yeah. They're almost identical, except this is doubled and opposite. So let's say I'm just trying to solve it. I could multiply this top one by the bottom one by what? By 2. Or I could multiply the top one by 1/2. Either way, let's just double this one. Let's say I did notice it. I'm just going to multiply the bottom one by 2. Okay? And I'm going to try to eliminate. And so let's do that. So again, the top one stays the same. 4x minus 12y equals 22. Then we got negative 4x minus 12y equals negative 22.
Zero.
Yeah. You're going to get 0 equals 0.
Put -12 and -12.
Oh, I didn't mean to do that, but that's an easy fix because it should be positive. Thank you. Okay. 0 equals 0. Is that true or false, though?
True.
Is 0 equal to 0? Yeah. 0 does equal 0. Okay. So this is a true statement. Zero does equal 0. Therefore, infinitely many solutions. Okay. So I just want to point out on the assignment, and when you're doing this, what you want to look out for, guys. Okay, so if we're solving a system, right? If we're solving a system and you end up at some point halfway through the process with x equals something or y equals something, you got one solution. If halfway through the process you end up with some false statement, usually 0 equals something not equal to 0, 0 equals 7, 0 equals -3, you got no solution. If you end up with 0 equals 0, you have infinitely many. Okay? All right, so that's the notes. The assignment is on Delta Math, and basically that's what you're going to be doing, determining if you have one solution, no solutions, or infinitely many.